Hey people, so there are a few mathematical functions that you should know, like for example finding primes or to check if a number is prime or not. So let's just start with the number itself. We'll just call this number 23 for now. We'll convert it later into dynamic. For now, we want to put that every prime number, it's true. The prime number has to be true. Doesn't matter. You could put 23 or 25. Doesn't matter. Our starting assumption is that prime equals true. Now we can start with 4I in range. Now we'll start with 2 because 1 technically doesn't count. So let me just write out the program. I'll explain. I'll just put the number, the square root of number, and I'll add 1, and I'll just say if this number happens to be divisible by any of them, I will just say prime equals false, because remember it only takes one single extra factor to prove that the number is not a prime. Okay, we'll go along with that, and we'll just immediately break the loop because there's no reason to go on. If prime, that means it will just basically check if it's true or not. It's prime. Let's go all caps. So not prime. Let's run this and let's see what happens. 23 is prime. That's true. Let's try 25. 25 is not prime. Let's try 2. 2 is prime. 3 is prime. 4 is not prime. 5 is prime. 6 not prime. 7 prime. 8 not prime. We can go on in theory. You can go on for as long as we want. How about we just add one extra addition? Because number equals j, and we'll just add a for loop for j in range 2 to 100. Yeah, that's it. Let's do 100 first, and we'll just copy the entire code and we'll shift it here. And if the number is prime, what we'll do is we'll just print that said number. Okay, so what should happen is we should get a list of all the prime numbers. Instead, you know what, we'll just make up a list. Just say p dot append the number, and then we could just print p. So yeah, that's it. Now let's just go from over the start of what happens. So this is the logic which checks if there's a prime number or not. So we input a number and it's prime from the starting, but then it goes through 2. It starts from 2 to that number. Well, not exactly that number, but a square root of that number. It just helps in maintaining efficiency in the program. That's it. If that number happens to be divisible by any other number smaller than it, so let's say 25. Now 25 happens to be divisible by 5, and the remainder is 0 if it's perfectly divisible, then prime is equal to false, and then we break out from the loop, because it doesn't make sense that once you have checked 5, you do not go and check other numbers. So then you say if prime. Now this basically means is saying if the value of prime is true, then do this. If the value of prime is false, then do not run this at all. So p dot append number. Oh yeah, so this is our main for loop. This main for loop just basically it just cycles through the numbers 2 to 99. That's it. So this j keeps on changing, so 2, and then it goes and checks if that 2 is a prime, then it gets appended, then it goes to 3, and so on and so forth, and we finally print p. So this is the prime number function. We could actually go 10,000. Let's see, why not? Yeah, so these are the first, well, not first 10,000, but this is from 1 to 10,000. As many as primes you want. You could go to 100,000. Why not? It will take a minute. Yeah, it just takes 1 second. You could go to 1 million. Let's go to 1 million. I think it's gonna take 10 seconds. Let's see. At least it should take at least 8 seconds, because we just increased the factor by a 10. I hope my laptop doesn't crash. Yeah, I don't think that's gonna work. Oh, it did. It just took time to print those out. It took 20 seconds, and now we have primes from 1 to, well, 1 million. Isn't that fascinating? While we are on the topic of mathematical functions, prime numbers, yes, they are very important. The other thing important is the factorial function. So we'll just write factorial. Let's find the factorial 5. If you do not know what's a factorial, that's okay. I'll just explain that in a while. We'll just cycle through for I in range 1, 2, 5. Sorry, fact plus. I'll just keep this like this, and that should be fine. I don't think it matters if I put a 0 or a 1. Let's just go with it. So we'll see value equals value times I plus 1, and then we'll just say print the factorial is comma, this is plus, and then string value. Let's see. And yes, 5 factorial is indeed 120. What is exactly factorial? I am glad you asked. 5 factorial is denoted like 5 and then an exclamation mark. It's basically 5 times 4 times 3 times 2 times 1. 6, 7 factorial, let's say, would be 7 times 6 times 5 times 4 times 3 times 2 times 1. It's just you take a number and then you go down to 1, decreasing 1 by 1, and then you just put a multiply sign in between, and this is the factorial function. We could put up a 10, and yeah, that's the value of 10 factorial. That's it. So today we learned about prime and factorial functions. If you need me to make more videos like this explaining functions, we could go for bubble sort, and we could, there are a lot of functions: maximum, minimum, integration, differentiation, complex numbers. Please let me know if you want me to make a separate playlist for this. And yeah, that's it. Have fun, have happy programming.